Hello and welcome to the help video for the Binomial Theorem online exercise. Now, this video is not intended to teach you about the Binomial Theorem from scratch. I'm going to assume that you've learnt that in school already, and this is just designed for students who have maybe forgotten it. So it's a bit of a reminder so that you can answer the questions in the online exercise. So what is the binomial theorem? Well, sometimes called the binomial expansion. It's a way of quickly multiplying out or expanding two terms that are bracketed together and raised to a power, usually larger than 2, because we can do powers of 2 manually. So here's an example of what it looks like. So after those brackets have been multiplied out, you get all of these terms, and they're written in a specific order to make it quite clear so that you know you haven't missed any out and you haven't got any twice. So the coefficients, these are the numbers in front of the letters, they are to be found in Pascal's triangle. So the numbers in the rows of Pascal's triangle, each number can be calculated by adding together the two numbers immediately above it. So for example, the number 10 in the pattern was found by adding together the 6 and the 4 that are immediately above it. Now we class the first row of Pascal's triangle, the one with just the single 1 in it, as row 0, and then start counting with row 1 as being the row with 2 1s in it, and so on. And also the first term starting on the left of each row is term number 0, and then it starts counting 1, 2, 3, 4, and so on as you go through the row. Now, there's also a formula for calculating each coefficient. So rather than writing out the whole of the triangle for maybe some big numbers, you can actually use this formula for calculating the coefficient, where n is the power that you're raising the two terms to, and the letter r is the number of the term in the expansion, remembering the first one is term 0. So this is going to be helpful when we just want to work out a specific term, or maybe quite a big one. And this formula, sometimes it's called the choose or the combinations formula, and this is how you would work it out using this notation. So let's say we're looking for the coefficient in the 5th row of Pascal's triangle, and we want the third term. So we put the values 5 and 3 in place of n and r into the formula, and we calculate just like this. The exclamation mark means factorial. It means we multiply the number by each of the integers less than it, or each of the positive integers less than it. So for example, 5 factorial is 5 times 4 times 3 times 2 times 1. And then on the bottom of the fraction, 3 factorial is 3 times 2 times 1. And then in the brackets, 5 minus 3 is 2. So 2 factorial is 2 times 1. Now, that fraction there can be simplified because we can see there are some common factors in the numerator and the denominator, so we can cancel or divide top and bottom by 3, divide top and bottom by 2. There are some other things we could divide top and bottom by, but now I think it's probably simple enough just to do the multiplications in your head. So 5 times 4 times 1 on the top of the fraction, of course, would be 20. And on the bottom of the fraction, 1 times 2 times 1 is 2. So the top of the fraction is 20. The bottom of the fraction is 2. 20 divided by 2 is 10. So, bit of a long process, I suppose. But there's a button on the calculator right there on my scientific calculator. And if you have a TI Inspire, go to probability and combinations, and you could actually work out the whole row of Pascal's triangle all together. rather than each term separately. So if we are multiplying out a plus b to the power 4, this is how you would set it out. So using the brackets notation for the combinations, we have 4 choose 0 as the first coefficient, and that will give us the highest power of a to the power 4. And then you should see the pattern of the powers of a decreasing as you go through the terms, the powers of b increasing as you go through the terms, and the little formulas in the brackets are basically working out the terms of Pascal's triangle for you. So if we were looking at something a little bit more complex, rather than just a plus b as our binomial, if we were looking at 2x plus 3y, it does get a little bit more complicated, because in the big tall brackets you can see the terms from Pascal's triangle being generated. But then when we raise the two terms in the brackets to the powers, we have to remember that the coefficients of those terms also have to be raised to the powers. So that's why I've put brackets around the 2x, for example, and brackets around the 3y. So you're also going to work out the numeric values of those as well. So it can be a little tricky, but here's an example of a way that I think you can do it quite quickly. Here's 2x minus 3y to the power 5, and the first thing I'm going to do is just quickly jot down Pascal's triangle, because I think for a number like 5 it's actually quicker to do that than to go to the calculator. So I'm actually doing it upside down because I want to end up with the 5th row right up here as the initial coefficients of each term of my expansion. And actually I don't need the rest of Pascal's triangle. I can rub that out now, get rid of that, and I've started now by writing down the 5th row of Pascal's triangle. So now I have to consider the 2x. Well, let's just consider the 2. And that 2 is going to be raised to the power 5 for the first term, that's 32, and then 4 for the second term, that's 16, and so on, all the way down to 2 to the power 0 at the end, which is 1. So those are just the powers of 2 that come from the first term. Now I'm going to look at the second term in the bracket, and ignore the minus sign for the time being. It's a 3, and I'm going to do it in reverse order. So starting from the right, I'll put the 3 to the power 5 down, which is the 243, and then the 81, which is 3 to the power 4, all the way down to 1 on the left. So those are all the powers of 3. And now I'm just going to fill in the letters, because that's a nice and easy pattern to write down. You can see the powers of x decrease as we go from left to right, and the powers of y increase as we go from left to right. So that's a nice pattern. It's easy to see if you've made a mistake. So now I need to multiply together everything that I've got there to get my final version of the expansion. So 32x to the 5th is the first term, but now I've got that minus sign coming in because the minus 3y is coming for the first time into the second term. So I will work out 5 times 16 times 3 times x to the 4y, but there's a minus sign in front of it. Now the next term, the minus sort of cancels itself out because it's being squared. So I've got 720 x cubed y squared, and as you can see, the positive and negative signs alternate now in this expansion. Doing the maths in your head, 5 times 2 is 10, 10 times 81 is 810, x y to the 4th, and then finally minus 243 y to the power 5. So hopefully that's proved a timely reminder of how to do binomial expansions. Try the online activity yourself. You can see the address there. There are lots of other activities that you can do on Transom building up to this. Good luck, have fun, enjoy. Bye.
You can find Transom Mathematics at www.transom.org, where you're welcome to use all of the activities absolutely free. or jump in with both feet and become a Transom subscriber.